It's
Wait. Hold up. Sorry, Professor. I wanted to ask a question about
sure.
the
Go ahead.
observations. Is the exposure time for the Prompt 5 telescope 0.1 seconds or an eighth of a second?
For the one on the moon that we talked on the Tuesday, you mean?
Yes.
Yeah. For the prompt 5 is 0.1, and for prompt 6 is 0.125, based on the MWU word form that I sent it to you.
Because on the Prompt 5 word form it says if you're observing with Prompt 5, your exposure duration should be an eighth of a second.
No, no, no. It is whatever on the table is that uh, uh, a 1/8 of the second. 1/8 of, let me see how much it is. Let me see.
On the chart, it's 0.1, but on the image below that, it's 0.125.
Yeah, yeah, th those is the kind of different data that we had. Because as a professor on the video that you say, Professor Dan says it's going to change it year by year, term by mostly several years at a time. They will update it that one. But whatever you may see it on the video, different things that is given on the Word format. But whatever is in the Word format is the final one that you have to use it. And you will notice it on the WebAssign table that you see it on the WebAssign is different than the one that is given on the videos, because videos are recorded many years ago and may not be applicable for the final one that is recorded on the WebAssign, or I give it on the MWU on the Word format. Therefore, whatever you see it on the WebAssign is final, and whatever I give it on the Word format MWU is the latest one. And whatever else you see it on the others may not be accurate and the final one.
Got it. Thank you.
Thank you. You're welcome. Let me share it the screen for the.
Yeah, chat is open also. I made a couple comments over there as you're opening up because I did do prompt 6 and I got good results with the recommended values, but there will be a range of values that should work for
Okay,
all of these.
no problem. Let me share it again.
And you might think also perigee to apogee. There's quite a bit of a range of the position of the moon, anyways, and I know I've taken images like to look for the moon of Jupiter and images to look at Jupiter, and you can use actually both of those quite often to do both jobs by adjusting things in Afterglow.
Okay, I just try to make sure that make sure I'm just sharing several items together. Hopefully, I will double check to ensure that you see it all of them together or no. Let me go first uh, to the lab tree. Do you see the lab tree WebAssign on the screen?
Yes, it's coming
Yes.
And,
up.
and also this one, it shows the entire schedule of the WebAssign. Do you see it?
Yes.
Okay,
Yep.
very good. Okay, here on the lab tree, we just go over last time on many different things that we had in the consideration. One of the activities that we're gonna do to investigate later on this session about the geocentric and heliocentric system, but mainly whatever we're gonna investigate here, measuring the moon's orbit around the planet. And we have several options. Mostly we do on the gas giant. Those are exterior moons beyond the Earth um, kind of orbit around the sun. And the other ones that we're gonna investigate, the one that is inferior. Inferior is the one that is closer to the sun from Earth, like a Venus. That the one that we're gonna look through it hopefully today. And the one that we investigated, yes, as week, we have several of them. That is gas giant. We call it exterior planets: Jupiter, Saturn, Uranus, and Neptune. And for each of them, we choose the one of them. You can choose another one, but for the WebAssign, it has chosen, for example, Jupiter Ganymede, Saturn Titan, Uranus Oberon, and Neptune is Triton. Therefore, each of them that is available for you, you can use it, and whenever you have chosen and they get the data, you choose it on here and provide it on table. And we're gonna go over this data that is provided, how we can do that. But for the procedure, you normally we do the on a SkyNet, we provide for example, Jupiter, Saturn, or Uranus on the section for the selection. For example, I will show you here. No, not here. Is the sky. Let me go open a SkyNet again. When you log in on your SkyNet and you come over the observation, do you see the SkyNet on the screen? Okay, then
Yes.
you add the observation. You just say Jupiter, for example. And for the observation of the Jupiter, you've come here and identify first. You just identify a specific name for it. Normally, on the lab one, you identify the Jupiter as well, but here on lab 3, we're gonna specify moons. Therefore, I added here Jupiter moons, and for example, November 14, November 2025, and my initial, something like that for you that to be identified. The reason is that because if you just put the Jupiter here and you gonna be overlay with the one that you already done with the lab one and cannot be specific. Therefore, as much as we go further, if you identify object observation name more specific, it might be easier for you later on to catch up on your observation. And then here, make sure that minimum target elevation 20 degree, that you have more time available. And as you see it here on the graph at the below of the first session, you have many of the telescopes is available. You can use it. And here, the other options, we don't need it advanced setting, and we're gonna go to the next. And here on the option that we have, we look through the lab 5, whatever is given. For example, Jupiter is V 0.03, the filter is V, and for the others, high true. And I mentioned earlier on the lab 1, high true is the one for the very faint object. For the object that are very bright, we use different filter that are already given on the WebAssign. High true in here, if we go back here, and let me see what we, yeah, here. When we choose in here, we're going to use V for the moons, and then continue to next step. In here, you can choose all the telescopes, but we recommend that use the prompt telescopes, that is prompt 5 and 6 is better because they have a high on the mountain and quality might be better. And then you come here on the lab 3, you're going to choose 0.03 second for the Jupiter. Therefore, go back here, one exposure, 0.03.
Now, at this point for efficiency, are they picking generic 16-inch at the top again?
Yeah. Thank you for reminding. Here, always we have to make sure that we have to choose here. Doesn't matter of the number of the telescope that you're choosing. Always on this exposure, as you see it on the top here, I highlighted by my mouse, target filters. First, we just identify target. We say Jupiter's moons, then filter V, then telescopes. We choose the prompt 5 and 6. As you see it here, prompt 5 and 6 is chosen. But here, always, when we come to the fourth screen, we just choose the generic 16 and identify 1 and 0.03 that is given on the WebAssign table. Here, V 0.03. That is very important. We choose this one because if we choose based on the generic, when we go over the 5 and 6, it may change. As you see it, is not 0.03. But when you choose the generic 16, 0.03, the program SkyNet itself automatically chooses whatever duration is matched for each telescope that is you have chosen. Thank you for reminding, John. And then for this next one, after you choose and everything is all right, here we're gonna choose the 14th session. How we're gonna do that? We're gonna say repeat, and 14 times, and at least 1 day between them. It means that when it chooses the one picture, it repeat 14 times. You don't need to redo it. This algorithm in advanced setting, normally, sometimes remember that sometimes it's gonna be like this. Advanced option is hidden. Therefore, you have to click this arrow that is open up. Then you say the sequential filters. Continue on the next available telescope. If you choose 2 telescope, you're gonna see this message here. If you choose 1 telescope, you don't wanna see this here. Therefore, because I have it here, 2 telescopes, you have to make sure that this click here. If the first picture is chosen for prompt 5, the next one gonna be available on next available telescope. If 5 is available, there's gonna be 5 or 6 available 6. That is, make sure that continuously taking the pictures back to back. Then repeat the observation 14 times. Why 14? The 14 is chosen because we're gonna take a picture of the 14 days back to back to make sure that we have grasp of the whole um, orbit of the moon around the planet. For example, here Ganymede around the Jupiter, and we're gonna go over today, see how we can work on those. And when you do that and save and continue, and the last window is the review. On the review, you have to make sure the name is chosen is correct, Jupiter target, and other items that is important, prompt and telescopes is chosen here. An important item that you have to double check is exposure. The filter is V, one picture, and each picture is 0.03. This 0.03 is the one for generic telescopes, but for each telescope, SkyNet automatically gonna choose appropriately. Here, repeat 14 times, 1 day between them, and this is also 14 pictures you're gonna choose. And here at the end, you're gonna see 14 credit gonna go away, and because you're gonna take 14 picture, and you click and submit. Therefore, this is again procedure for the taking the picture from SkyNet, and that is done, and you have to look through it accordingly. Any question on this procedure again? Okay, thank you. Then we come back. I close this one because I have open another SkyNet here. When you have on a SkyNet in your observation, you see a lot of observation. I have it here, but yours might be not few, but it's not important. In here, the next step, you're gonna come open the Afterglow. And when you have opened the Afterglow, you will see different pages here. I have open here, previously I have uploaded here, but whatever you're gonna do on Afterglow, let me close it. This one, I show you something else. Let me close. Yeah. Here, normally when you have on the SkyNet, when you click Afterglow, let me close this one to make sure that I show you what I would like to see. When you say the open Afterglow, let me log it out. Wait again. When you see the Afterglow, you see a picture like this. Do you see the picture of the Afterglow? Okay. Here you can sign in or sign on a password different, but I recommend to use the same login that you have on a SkyNet, because that is save a lot of headache to have different user ID and password for different things. When you do the login on SkyNet, it's gonna bring for you the Afterglow based on your same login that you have on the SkyNet. Here, you have opened the file. You have to come to the upper left, click on this icon, Afterglow, and you have several options. Two of them, we're gonna look through it. This is sample data that is provided for the educational purposes, and we're gonna use the Astro 101 lab. As you see it here, we have lab 3 available, but here we're gonna go later on after Venus. But right now, we go back here for your own observation. Whatever you requested from SkyNet, you have to come here, the SkyNet Robotic Telescope Network. And then here you are consider yourself as a user, and you see if you have ask from SkyNet for observation, you're gonna see a bunch of items here. But whatever you needed here, Jupiter. For example, I assume you take a Jupiter, a name. As you see it, I have different Jupiter's observation here. You choose the one that you already identify with the moons. And here is identify here. For example, whatever you see it, no moon here, it means that I take it only picture of the Jupiter. But whatever it is, moons are there, is taking for the observation of the moon around the um, orbit of the moon for the lab 3. You can identify here, for example, for your identification, you say Jupiter Moons Lab 3 to make sure that you that is differentiate from Lab 1 as well. This is up to you, whatever you choose it. Then I choose this one, for example, whatever I do that in March 25, 2025. When you come here for the moons, always choose and also on the other pictures, you choose the radius images. Radius images, if you go back here, we have 3 folder here, reduce images, raw images, and master calibration images. Only we use this one because this one already by the SkyNet, they did some post-processing to get ready for this activity on lab 3. Then when you come here, probably you're gonna see 14 pictures. Probably it's gonna start from here to down. It's gonna be 14 picture that you already selected on the SkyNet. Click on this square here. When you click in here, all of them gonna be selected here. When you select it, and then click here on the lower right, open. And it takes time because it is gonna be sometimes to upload these pictures that you have chosen on the Afterglow. Any questions so far?
No, this is really good. And just a reminder that these images will grow every night. So if you're looking and you're only seeing 2, that's because you wait for the next night, you have 3, then 4, and they'll kind of grow. And what we're doing, you can do, you have to wait for all 14 to be done as you do this. And the different moons have different cycles at which they go. So you're going to see some of them move a lot, and then some will be kind of slow going around Jupiter, which is very cool. I was looking up the numbers real quick, and like, for example, Europa, it's 85 hours. It goes around in 85 hours. So a little more than, 3 to 4 days, it does a loop that quick. Io is half that time. So some of its moves really quick, but then Ganny, 172. So now we're talking, talking weeks at that point. And Callisto, which is 17 days, which is over 2 weeks. And so the moons all move at different rates, but they're wonderful to watch because you can actually see some of the quicker ones like Europa and Io through a one-night observation. You look at it a couple hours later, and it's shifted, and it's usually very obvious.
Yeah, and that's good. And also that is one of my 40 years ago memories. That first time I looked through from my 2-inch department store telescopes to the Jupiter, and I see this full moons. I believe it was around 10 a.m. or 9 a.m. about 40 years ago. And I was excited. Oh, I see like a Galileo, the four moons of the Jupiter with a small 2-inch or 50 millimeter telescope. And then I'm as excited and keep looking after I go back or inside and come back and look through after 1 hour, 2 hours. Still, I don't remember how many hours, but I see these moons are moving around within an overnight in few hours, and that is also shows that how that is this moves. If we taking the pictures, we see it here on 14 days back to back. They are moving very quickly around the Jupiter. Okay, first thing, then we go here. This is the first one. This is the second one. This is the third one, and fourth, and back and forth. But for each of them, as you don't see it here, you just remember this 5 items on the lower right. Here is reset the zoom, fit the zoom to the feet. When you say zoom the feet, it brings everything in here. And you see it here. And you can do it zoom out, zoom in, and you can do it by mouse, going to the mouse play and zoom in and zoom out. And this too is taking for the export the image as a JPG or download viewer snapshot, whatever is proper. And for the recording of your observation, if you need it, when the lab 1, 5, 2, 3, 2, not 2, lab 1, 5, 3, 4, 5, you need to export it as a JPG and save it and upload it on the lab assignment if you need it. Not for this one, but the one that is requested on the, I just reminding this one, remember, always you do that. For this one, we just make it zoom to fit. And few items here is very important. Here is default setting, and here faint object, and here is bright object. You see on the bright object, if I zoom it in a little bit to see it better. This is Jupiter, although you cannot see it bright target, but if you here, there is an option here, saturation level. You can change it this one to percentile that you had. You can see it different visions. If you bring it down, you see beside it, you see two moons. Before you don't see it. And then when you play with this percentile saturation, you can able to distinguish moons beside the planet. Okay, here I just zoom it out a little bit to see sometimes the moons are very far away. Anyway, this is a way that you're gonna see it on the first, on the right side of the Afterglow, you have many icons here. You can use it. This is the first one that you can play and zoom in and zoom out and through the identify saturation levels. The next one is very important to give us the data that we needed. And the other one is the show platter. In the videos that Professor Dan provided on lab, you may not see it. You may see something else differently because those was provided based on the older version of the Afterglow. You may see different things, but all the activities are same. If you review the Professor Dan's tutorials on the lab as well, that's good. The one thing that we can do before starting to go to the next item, you need to better to have a spreadsheet. I click on the spreadsheet. Hopefully you see this spreadsheet. Do you see it? Good. Here, the
Yes.
spreadsheet, I just provided, you can do it whatever you like it. I do it in my topic. Topic is lab 3, angular separation of the Ganymede from the Jupiter. And the gas giant planet is Jupiter. Natural moon is Ganymede. And I added here some data. This is going to be, we're going to record it in our observation. We're going to have 14 observation. For this, each observation, we're going to identify 2 items. One, time, and we're going to say about the Julian day, what is this? And separation, arc second. And this is the actual time of the observation based of the UTC. If you go back to the one that we have it here, on the Afterglow. The time and the time is going to be identified by this I item here, second item from the top. Normally, it shows several different items here. We can put a time like a time of the day that is the start of the time and what the time that is picture taking. But the problem here we have, for example, 2025 03 March 12, and the time is 12:27 and 0. GMT is the same as the UTC, General Meridian, the Greenwich Median Time, or UTC is the same, two different designation. But all of the pictures is taken on Afterglow showing is based on the UTC or GMT. The other things that you can do, you can click here and you get the data differently. Let me see here. Yeah. When you have click here, show raw header data, you see many technical data. You don't need to worry any of them. But two things is important. One is the time that is taking here. This is the actual time based on the day and the year and month. Another one, you come down, you see Julian day. You see Julian day? Here is Julian day. You copy here, copy from here. You come back to the Excel file and paste it here. And then separation, we're going to go later on that. To see, you may ask a question, what's the Julian day? And then on the Julian day, we have, let me see if I open the file here. I'm going to share it with you, some items on the Julian day and what is related to that. Hopefully, you see it, this picture? No?
So right now we just see the Afterglow.
Okay, Afterglow. Let me stop sharing and come back here to share this. Okay. This is a kind of topic that we collected, John and I, last semester. We're going to share it with you later on. But this one is related to the how much, what the approach and the kind of system timing that we're going to use on the system that on the astronomy. Normally, Julian day is a kind of one of approach that we're using on the system that we have. And the time that we have it, this is also a document from Astronomical League that is provided a different time that we're using on the astronomy. Normally, one of the basic times that we have it to use for the different time of the year is different, but also approach that we're going to use normally is different for different time of the year that we have to use on the astronomy, on the constellation. Julian day is actually the things is that related to the specific time on the many a specific time on the before BC that is specifically chosen for a specific reason. There is no kind of guidance available. There is a history behind it, how the astronomer in the old days, they try to use a specific origin for the number of the days to choose it. Julia day, back to that, if we check it, for example, let me see on here, I check it, Julian day. It is kind of consider in here, let me share it with you. This is basic information that is provided for astronomers. This is, hopefully you see it, this is Julian day that is
Yes.
but on the NASA, you can check it and get the values as you need it for each time. And this is based on the specific data that we have it for the calculation of the Julian day. And you can have it if you click it and you can check it and do it. Well, you don't need it to do that, but for your information, you can check it with the reliable information on the data to see what the date is and how to calculate those accordingly. But going back to our previous presentation on Afterglow, in here an Excel file that we had, okay. Then first thing that we need to identify is the date that I mentioned in the Afterglow. We're gonna come here and identify from the I here. Next, on the separation. For the separation, we needed to do a little bit activity, very easy to do. On here, we have to click on the platter bar, 1, 2, 3, 4 icon from the top on the right. Then we come, first we have to see if we find out the Ganymede. Which one is the Ganymede? We see two of them. Sometimes Ganymede is behind the Jupiter, sometime in front of it. And we have to see where it's located. For this purpose, we're going to use a Stellarium. First, we need to know what time of the day we have. It is 12 of the March 2025, about 27 minutes after the midnight. Okay, we come to the Stellarium. We open the Stellarium. Do you see the Stellarium in my screen? Okay.
Yeah, we're good.
Then
Yes.
then you can zoom it out or zoom it in and do it as much as you need it. First thing you needed to do the Stellarium, you come to make sure that your data is based on the time zone of the UTC or Royal Observatory of the Greenwich. That you make sure that this is set up and this is UTC. And as you see arrow, red arrow on the here, it shows up approximately the location of the Greenwich Observatory. The second thing is you have to identify the time. As you see the time, what was the time? And you have to make sure that you open the both of them side by side to make sure that you see it both times correctly. Here I see the WebAssign 12 of the March. I will specify 12 of the March. You can type it in to be faster, or you can use it like this, 12. And then 27, 0, 27. Second is not important because it's always changing. So you cannot stop Stellarium always is going forward. But first thing, you just location, time zone, and you don't need to change location, time zone, and the UTC and the actual time of the observation. And you go to the check the target. Click here, target Jupiter, and bring it to Jupiter here for you. Let me see. I close this one. Okay, Jupiter is here. Okay, here, let me zoom it out. As you see, Jupiter, there is one Callisto is far away, and two of them is very close to each other. Which one is this is Ganymede, this is you, and there is another small moons or other side. We don't need it. Only we needed Ganymede. Then we go back to the here on our Afterglow. The direction is not the same. You see this one? If you compare it, it looks like they are not oriented properly. The things that you needed to do to flip and switch, you have to do it on here. You come back to you make sure that open the Stellarium. You come back on this first icon here, the display, and down below you have several icons here. Rotate, mirror, flip. Therefore, as you see it here side by side, I flip it. It looks like the picture is correct. Although you don't see it like here is Stellarium, very nice circular things, but here is Io, here is Ganymede. Therefore, you find out here. Here is a little bit difficult to measure the distances, but we're gonna do when it is very close to the object. Normally, you have to guess and provide this information a little bit not very easy. We're gonna do the next one easier. For the measurement, you come here to the plotter. You click the Ganymede is this one, somewhere on the center, as much as you can. And then drag it to the center of the Jupiter. Then when you do that, you see the measurement here. You don't need it to do anything. Here it's going to be 21.7 arc second. You don't need a pixel, you don't need an arc minute, only arc second. You copy, and you bring it to arc second here. You put it paste here. This is a measurement. And if you do it several times together, tonight, next day, and two, they are not exactly the same to each other because you are approximating the value that you have taken into consideration. We go right now to the next step quickly, whatever we learn. Just go back here, the next image. This one is much easier to see it. We bring it to center and we just play with the saturation on the first. Looks like better. We have to see which one is Ganymede. Then what we should do, we go to the Stellarium. Sorry, we go to the time. Click the time that we have. This is Julian day. Copy the Julian day to the Excel file. The second one. And then for the separation. For the separation, I'm gonna see what time of the observation was. It was 13 of the 1 day after 12, 13 of the March. Day time is 28 minutes. Then I go back to the here. Only I need to identify the time. 1 day after. Time is 28 seconds. Then I look through Jupiter. Jupiter is here. And then just zoom it out. Okay. Where you see the Ganymede, on right or left?
On the right.
Right. Okay. Therefore, one is very close. The one you have to see the pattern here. As you see it here, it doesn't look similar to that one. You see, this is Stellarium, and this is the Ganymede. It seems to be this two is one of them is Ganymede. Therefore, you have to come back here and flip it. Flip the picture. Mirror image. I did mirror image, and then let me see. When I do the mirror image, then I go back here, make it smaller. Okay, which one is Ganymede? The one is far distance here. This is the Ganymede. This is the Europa, and the one that is very close, we cannot see it on the afterglow, on the glow of the light glow of the Jupiter, we cannot see it. But only we have to measure from here to the center. Here is the one activity we're gonna do. Here, come to the plotter. On the plotter, first we have to click on the centroid. Then remember what we should doing. Then we go select this Ganymede selected. And before going to the center of the Jupiter, we come back and say planet centroid. And we click here. Any place here, you can click it. Automatically program calculate the center and identify that. The reason I show it that way, I click it here, because when you click planet centroid, it program is written on the SkyNet that based on the characteristic of the pixel, it calculates the best representative location of the center of the planet itself. Therefore, first, both of them is unclicked here, centroid click and planet. Click on the centroid, click on the center of the moon. Then as much as you come, click on the planet centroid, go to the center of the disk of the planet and click it. And then you measure the data that you have. How much it is? 220.94. 220.94. I measured before something else. I copy and paste here. 94. Here. You do the same thing for all of them. One of the key things that you have to remember, when you do this kind of saturation level, you don't need it to do all of them same experience that we did it here to measure the saturation to see the object clearly. You can come here, there is a setting for the workbench, click on here, and synchronize display setting. It means that whatever you're choosing for this display gonna be applicable for all of them. You don't need it to repeat this task again, but you have to repeat for the measurement of the time and also the separation again, but you don't need it to play with the saturation to observe to see the moons are observable. Then when we do that, this is kind of basic thing that we needed to do. For the each measurement, we needed to measure the time, Julian day, and separation. That's the only thing we needed to do for this 14 observation. Any question? Okay. Then next item that we're gonna do is gonna be, we go to the Astromancer. Let me see, where is the Astromancer? Here. This is the Astromancer that we have. Let me go first on the beginning. Click on Astromancer. You choose on the Astromancer, we have several graphs. You choose OPIS, this is MW, we're gonna go on the MW, but on OPIS, you're gonna have on MW and choose the moon. And when you choose the moon, you may not see these items. Let me delete this one. You may see something else like this. It's gonna be all of them like this. This is a kind of model. We call it, this one is model, and we don't have information. Here is Julian day, here angular separation. We come back to the data that we have. We copy and paste on this Excel file. Control V, Control C, Control V, and we see all the data that we have here. But we don't see the model. Model is here. You see on the bottom? Do you see the Astromancer? Yeah, good. Then you have to play with this one. First one is the amplitude, and this is a kind of period and phase we're gonna see. First, we have to make it this one larger as much as it comes match with the data that we have roughly. Then we play with the period to see this model.
Yes, it's coming up. My computer locked up
Army,
for me for a second, but everything looks really
do you see it, John?
good, boss.
It sounds like there's some lag on your end, Mr. Taylor.
My end is lag. Might
Not on
be
your end, Professor, on Mr. Taylor's end.
okay. Okay. Therefore, here, whatever you do here,
So we're
just
getting
bring.
some
Go ahead, John.
lag in the feed on the Zoom feed for some.
I don't know. Might be related to my. It seems to be sometimes my internet speed is coming and going down and fast. But anyway, here the one that I described it on the Astromancer, whatever I repeat again, Julian day and the separation that you have here, copy and paste on the Astromancer. You selected the moon and copy and paste on here. When you copy and paste, you play with the this 4 toolbars here to make sure that you become closer to the point of the data that you have observed based on your observation. As you see it, they may have 12, 10, or 15 or 16. Whatever more observation you're gonna have, the model gonna be matched better with the data that you have. Then you play with the numbers and also phase. As you see it, I move it, it become closer to the data. Then I play the tilt and again play with this number. Also, you can add numbers on here also. You can type it out. But as much as you can, just try to match with the data that you have. It seems to be, this is a very good fit. Not exactly, but it's gonna be. as much as you are comfortable with the data. For example, here, the only things that you needed to record is the one amplitude, and this is period. And 277, and let me go here. We provide here 277, for example. And what else we had here? Period 7.6. 7.6. Yeah, we already have it. Therefore, this data that we provided by Astromancer, we're going to use the formula that is provided on the, what they call it, the WebAssign, and check it accuracy. This is the actual measurement that I get it from the NASA website that I send it on the email for you for the planetary data. As you see it, the period that we are observing here, 7.06 day for the Ganymede, and actual data is 7.4, very close. I mean, we are very good on that. And also, when we're gonna, this is a semi-major axis that we have. This is based on the arc second. And the reason is that we just seeing only the angle separation between the um, um, between the planet and the moon. And how we can get at the data? We're gonna go back to the observation that we have on SkyNet that we had here on the WebAssign. We calculated this data, and we measured the semi-major axis based on the playing with the graph A and P. And after we get those data, we can do the procedure B, calculate the distance, whatever this Stellarium gonna give a distance of the planet from the our image. For example, here we can go to look through the how much distance we get it on here from the Jupiter. We can go look through the SkyNet Stellarium, and here we have too many data. Let me read out all the information. Gonna be this distance gonna be 5 some AU, similar one that we, yeah, 5.171 AU distance of the Jupiter from us. Therefore, we just provided here on the data on the Excel file that we had 5.2, and then based on that we calculate the remaining part of the lab assignment. This is you don't need it to memorize any of this formula. All of the formula is given for you on here. They just calculating the lengths that you had here based on the degree. You calculate the all the circumstances of the orbit, and then based on that you will get the semi-major axis A value, and then all the orbital values going to be calculated, and at the end, based on the uh, Newton law and Kepler third law, we get the mass of the Jupiter. And as you see it, this mass of the Jupiter going to be calculated easily on this way. Any question? Next item.
No, it looks pretty good. We're getting close to the top of the hour.
Yeah, we are close
But
to the top of the hours,
I,
and probably next one, this one is very short. It's going to be 10 minutes, but we're going to do it on next session, next Thursday, for the measuring the Venus measurements. So this one is very short and quick. And this is one of the key things that we can investigate to prove that our solar system is heliocentric, not geocentric. Any question? Did Rowan and Arab,
Everyone doing okay?
yeah, did you submitted your 14 images yet or not yet?
I currently have 4 of the 14 images,
Oh, you
so
get it 4. Okay, good, good. Thank you.
Yeah.
How about you, Arab? Did you?
I haven't yet. They're still coming in. So
Okay, good. Thank you.
Okay.
Hello, Bishal. I don't see. Thank you for joining uh, us tonight. Okay,
he might be AFK.
okay, no problem. Okay, anyway, any question for next event? Okay, next week we're gonna go do the Venus observation. And for the Venus observation, you don't need it to take a picture because Venus is very difficult to take a picture. And we're gonna use the sample data on Afterglow for the Venus, and that's gonna be quick. And probably next week we're gonna go lab 4. That on the We're gonna have about 15 minutes on the beginning, lab 3, end of the lab 3, and then we go lab 4. And hopefully by that time, all 14 of your pictures ready and your data for the mass and the orbits are ready to calculate it.
Yeah.
Very
A couple
good.
things to notice. I do believe Jupiter and the moon they may have passed each other. So your observations for Jupiter might be hiccuped a couple of days just because the moon
Yeah,
causing
because of the
interference. Just be
location.
kind of
Yeah,
aware of
exactly.
that.
Might be, yeah. Okay, and
It's good.
if we are on the top of the hour, hopefully have a good evening and night, and see you on next Tuesday. Next Tuesday, make sure that we get ready for the previous discussion that we have for the mosaicing, and hopefully the pictures are ready. If you can submit it tonight, it's very close to the full moon, therefore the pictures may be not too bad. But if you wait for a few days, it's gonna be not full moon. That picture may not be good. Therefore, as long as you're ready, we can do the exercise on that and first activity on mineralogy and see how we can identify the different minerals on the moon and how we can color it and stitch together.
Quick little announcement too. There's a star party at Marvin Ridge next Wednesday. So if any of you are around, from 8:30 to about 8 to 9:30, we're kind of looking up and we'll see what we can see. Daylight savings time is going to bump us a little bit possibly, but we may go from like 8:30 to 10. But
Very,
Jupiter and Saturn are up and the moon will be out of the way. So we'll have a chance to really see some stuff and hopefully some clear skies.
very good. Thank you. Hopefully, let me put in my calendar, is the one that is gonna be 6, let's see, 6. It's gonna be 12 of the November, right?
Yes, November
Very good.
12th. And feel
Very,
free to bring family members along with you or friends from other
yeah, yeah.
classes. They can come in also just to have some fun looking through
That's good.
telescopes.
Yeah, everybody. And also, I think if you put something, John, I put it on the email group, or you're gonna inform them on the school.
Yes.
Okay, good. And also, do you start setting up the telescopes before 8 or 8:30 gonna start, or how it is planned?
Usually I show up about 10, 15 minutes before, about
Before.
7:45 and start setting them up. And students who show up early like to set them up too. So we kind of set them up
Yeah,
together. I've always was way ahead, then I sit there and they miss out on the opportunity of actually putting them together sometimes. But I do know the eyepieces need some time to equalize out and the optics
that's
to
right.
equalize the temperature and that kind of stuff. So we'll probably the radio telescope out also at the horn, just kind of trying to listen to things up in the sky if we can also. So
Very good. That's gonna be
yeah,
exciting. Thank you,
yeah, it
John.
should be fun.
And also, it's gonna be one last question. Is that near the stadium, the
It
game
is. It's
field,
right on
right?
the top of the hill on the bank looking down to the stadium. And we've been lucky that the lights are out. Sometimes there's a game on, but usually I usually schedule when there isn't a game. And then like the junior high or middle school has a game. And so or somebody comes in to use the stadium and the lights are on. Even with the lights on, we've had pretty good luck observing things in the past, or we might move on the other side of the hill. Just look for the orange cones
Okay.
and be a lot of orange buckets is what we have out and the telescopes.
Very good.
Oh, we
Very
do
good.
always ask, make sure watch your headlights coming in so you don't blind everybody. That's a big one.
Exactly. That's a good point for the star party. Thank you,
Mr.
everyone. Go ahead.
Mr. Taylor, do you know how National Honor Society induction will fit with Star Party because they're on the same day? And I think that there's like also a volunteer activity after school.
Next Wednesday?
On the 12th, correct?
Yeah, I thought we missed everything. I'll have to check the calendar. Yeah, we kind of deliberately pick dates when there's nothing going on. So there is something going on next Wednesday, you're saying?
Yeah, National Honor Society got pushed back a week because Mr. Burns had to go to the Midwest for whatever reason. So, yes.
Oh, okay. Well, I'm not sure when you're done with, if anybody's going to that afterwards, come out and check out the Star Party. If there's anything going on in the evening, just, we're later than everybody else because we're going to 9:30, 10. So if you're done with something, come out. Nobody has to stay or stay very long, but come and look through the telescopes. And baked goods are always a welcome too. If you want to bring cookies or anything like that with you, I usually bring moon pies or something fun. So same with the
That's
theme is
good.
kind of good too.
Mr.
That's good.
Taylor, should somebody bring hot water or something like that as the days get colder?
Bring some cocoa. I always like some hot chocolate's always good. Hot tea, stuff like that. Usually everybody kind of brings their own, and baked goods, people just kind of bring them in. Some people are better baking than others, but rock or soft, we kind of enjoy what everybody brings. So we have fun.
That's gonna be good. Thank you. And hopefully we'll see each other and hope we have a good evening and by next Tuesday.
Yes. Have a good weekend, everybody. We'll see you
Have a
some of you
good one.
around. See you
Have a
later.
good one. Bye bye.
Bye.